All right, good morning. Let's go ahead and get started. Oopsie, let me go ahead and go here. So what we're going to be doing today, find the vertex and the axis of symmetry of quadratics. So basically the same thing we did last time and the time before that. So we're still graphing quadratics, so we still got to make a parabola. And we use the vertex to graph the quadratic function, but this time we're focusing more on the vertex than we did before. So what we need to do is we need to put these, well, I don't think we need to put them in a vertex form today, but we do want to have them in vertex form, and this is the vertex form. So it looks kind of similar. Ax squared, if you remember the other one was ax squared plus bx plus c. It kind of is the same. We have an x square. Well, we have to use FOIL. We'd get the regular x, and then we'd get a regular number. But in this case, we have our regular number split into two other parts, the h and the k. The important thing with this one is that h is negative in the formula. So whenever you have a formula where any variable is negative, it's going to be the opposite of that number. So when we take the h and k, so without the h is without the negative, then we get the vertex. And we also have an x equals h. So if you remember, this is a linear function. So when a linear line does not have a y value, that means it does not touch the y-axis, so you have a line that is just straight up and down. So that's your axis of symmetry. It's going to be along that line. And A, just like the other style, the other form, A is also determined whether it opens up or down. It also determines whether it's going to be compressed, stretched, or anything else like that. The vertex form shows the vertex, well, duh, on a quadratic function with respect to its parent function f of x equals x squared. So let's go ahead and look at the parent function. Oopsie, let me go ahead and move over to here. And I'm just going to type in, oopsie, still knows what I want. So click on Desmos, and we have x squared. So let me type in the square, which is this button here. And that is the parent function. That is the most basic form of the function. So we need to describe how each function compares to the parent function. So let's look at this first one, x squared plus 9. X squared plus 9. So x squared plus 9. There it is. So it's the same, it should be the same shape. I know it doesn't quite look like it. It looks like one might be bigger than the other, but as you zoom outward or zoom upwards, the shape kind of matches each other a little bit more. So if I were to change this to something like this, so I can change the value of a, right? If a is 0, then they overlap. But if I move it upwards, you can see that it's moving upwards and it's not changing shape. And it's going to keep going until it gets to 9. So that we have, that way you can see there is a vertical shift upwards. Oopsie, what was that? All right, so the graph moves up 9. And let's see what happens if we were to change that to a -2. So I'm going to go here and I'm going to erase the a here. So I just did that so you could see that the graph was the same shape, it's just moved. So the red one is our parent function, and the blue one is the transformation. So here, when I push -2, the graph goes down. So we know that this is a down 2 change. All right, it looks like we're going to have to type in a few more things. So negative sum of x plus 5 squared oopsie. And you can see that it's changing a little bit. So this one here is moving it sideways. So you can see that it's shifting sideways. Now for this one, we needed 5. So I'm going to put it right there at 5. And I think it was also negative as well. So that's going to flip it downwards. So you can see as I type in the negative or erase the negative, the line shifts downward. So this one has 2 movements covered. So it's reflected. And it's also shifting, darn, let's see if I can fit that in there without writing over anything. So it's reflected across the X and is also shifting left 5 units. Yeah, that's probably good enough. All right, and then let's go ahead and type in the next one, x minus 4 square, x minus 4 on the inside and then -1 on the outside. So get rid of this here, x minus 4. So you can probably guess what's going to happen when I change the inside number. All right, so it's moved over to the other side. So it's actually shifting right this time. And we also have the -1, which again, that shifts it downwards. And that's going to, well, shift it downwards. So right 4 and down 1 from the parent function. So you can see looking at the vertex, 0, 0, and 4, -1. Okay, I can't really make it stay. So let's go ahead and type that in. So right 4, and it is opposite. The inside direction, the H is opposite. Now, I cannot figure why, why they choose some of these terms, vocabulary or whatever. Like why did they pick H and K, right? Because usually when I think of H, the first thing that comes to my mind in math is height. But why? Why? Why did they pick H? I don't know. They could have picked like R and U or something like that. Probably not those, but I'm sure they could have come up with something better. All right, next one. Let me go ahead and type in the next one, which is going to be, it looks like they, well, 1/3 x squared plus 2. All right, now this one you can tell is obviously different. We can see that the entire shape is different. So in this case here, oopsie, let me go ahead and get back to the other screen. So yeah, you can see that it's been compressed and raised, or vertical compression. And it's been it's shifted up 2 units. Those are the changes that have happened. And let's go over to the last one. So I'm gonna go ahead and type the last one in there. So we have -2. All right, and that's going to shift it, or that's actually going to reflect it downward. So now it's opening down. And let's see, it's +4. So I'm gonna type in +4, keep an eye on what's gonna happen. All right, so it's moving to the side, and there is none of this last number here, so that, well, it doesn't make it go down, it just makes it not change compared to here to there. And I think, is that right? -2x4, yeah, that's right. So it's moved to the left and has been reflected across the x-axis. Ooh, excuse me. Reflect. Is that how you spell it? Yeah, I guess that is. Just the font looks different. And left 4. So reflected across the x-axis, a vertical stretch, and has moved left of 4. All right, so Mason graphed the parent of a quadratic function. He then reflected the parabola over the x-axis, translated it 7 units up and 3 units to the right. What is the equation of the new parabola? Okay, so, well, we have a couple of clues. We know that it's most likely going to be in vertex form. So f of x equals, and it says that it's been reflected, so that means that the first value is negative. And it doesn't say that it's been compressed or stretched, so I'm guessing that it's going to stay the same, so x. And we know that it's moved 3 units to the right. Now this is confusing at first, but this is the only thing, again, you have to watch out for, is that if you look at this one here, this one here, right is negative and left is positive. So left 5 plus 5. So again, we usually think of right as being positive, but it's the side-to-side motion is opposite. And 3 units to the right, so that means that it's going to be negative. So -3. And we have to put the square thingy on there, and 7 units up, so +7. And there we go. So that's how we would rewrite it. Everything else is, again, well, the up and down does match the way you would think it does. The up and down, up is positive, down is negative, but the side to side is opposite. And I think it was like that for absolute value functions as well. So if you remember absolute value functions, that one was also opposite direction from the way you might think. All right, let's go ahead and graph some of these. So find the vertex and axis of symmetry of each function or inequality and then graph. All right, so first thing we need to do is find the vertex. So we'll label it vertex. So that's the turning around point. Now it's going to be the opposite of this one. So you might think that it's -2, but in this case, it would just be 2. Let me write that a little bit better. So 2. And then over here, it's going to be 3. So that one does not change. And the axis of symmetry, I'll just call it A. Axis of symmetry in this case is x equals 2. So x equals 2, again, that's the line right here that our parabola is going to be reflected across. And this is a little bit faster because we don't have to find the vertex. We can just look at the we can just look at the formula in vertex form and immediately get the vertex. So we know that the vertex is going to be 2 and 3. So we don't have to spend any time. We don't have to spend any time to graph it. Now, if you remember the other day, or in the last lesson, I said that every parabola follows a pattern. So as long as there is no a value, you're going to get the 1, 3, 5, 7 type parabola. But if you don't remember that, that's fine, okay? It will make it go a lot faster when you don't have an a value. Maybe I'll do it for this one here, just to kind of refresh that. But let's go ahead and do what we've done before and pick some numbers for x that are above and below our line. Now in this case here, we just plug it in and see what we get. So I'm going to go ahead and plug in 1. So 1 minus 2 squared plus 3. And I'm going to plug in 1 because I'm going to check this one here. So 1 minus 2 is negative 1 squared plus 3. And negative 1 squared is 1. So that's 1 plus 3. And that'd be 4. But like I said, there's going to be a difference of 1 between these two numbers. And I'm going to go ahead and erase this so I can write it again for 0. So 0, now I'm going to replace x with 0. 0 minus 2 is negative 2. And negative 2, if I square that, so remember that's negative 2 times negative 2, that's going to be 4. And that means we're going to get 7 here. Negative 1, so negative 1 and negative 2, combine those, you get negative 3. Square that, negative 3, you get 3 times 3, which is 9. And remember, the negatives will cancel each other out. And that will make it 12. And for this one, actually, a lot of the numbers are going to sort of be the same. So let's go ahead and put in 3, and I mean the same because this one should be 4, this one should be 7, and this one should be 12. So 3 minus 2 is going to be negative 1. Wait, no, just regular 1. Well, even if I put negative 1 in there, it would still be the same thing. So 1 squared is 1, and that's 1 plus 3, which is 4. And again, I said that's what we should have expected. Let's put in 4 for x. 4 minus 2 is 2. And 2 squared is 4, so we get 7 again. And again, that's going to be the same as this. I mean, that's what axis of symmetry means. Axis of symmetry means that we are going to get the same thing on both sides. So if you ever get something different, that is an indication that, you know, something might have been missed. All right, 5 minus 2 is 3. 3 squared is 9, so we get 12. And from here, we should have enough information to make our graph. But like I said, there's going to be a difference in 1. So 1 over 1 up 4. Over 3 up 4. So a difference of 1. And then it's going to go like odd numbers, 1, 3, 5, 7. So if I go 3 here, that's going to be the next area that we got to graph. And I can't graph any more of them, so we're going to go ahead and we're going to just graph what we can here. Try our best to go through as many of those points as we can for our parabola. And again, parabolas are curvy, they're not straight, so don't connect the dots. And there we go. So that is graphed. All right, so let's go ahead and move on to the next one, and maybe we'll do this one a little bit quicker because, well, let's see if we can follow that same rule of odds. So 1, 3, 5, 7. All right, first things first, let's go ahead and get the vertex. So the vertex in this case is, well, what do I have here? Okay, what number is paired with the x? Well, 0. Because 4 is the outside number, right? It's not inside the parentheses or the group. So if, just like with all the other things we've been doing, when you have a formula and one of the numbers is missing, then it's going to be 0. So there's nothing there in this case. So 0, 4. Well, that makes it kind of easy. So 0, 4. And axis of symmetry is the x value. So in this case, x equals 0. And if we want to graph it, that means it's going to be right on the middle there. And x4, so that means that it's going to be, the vertex is going to be right here. Oh, wait, no, I'm sorry. That is -4. I looked at the formula and it's -4. So this should be -4 also. But we do know that this vertex is the middle number. So -1, -2, -3, 1, 2, and 3. Now again, I'm going to try to follow that rule of odds. So this is a way to do it a little bit faster. Now it only works when you have no a value, when you have nothing in front of the x square. Okay, when you have a coefficient of 1 or -1, I should say that too. When you have a coefficient of 1 and -1, like if this is 2x squared, it's not going to work. So 1, 3, 5, and in this case, I can't get to 7. And in most cases, you're not going to be able to because this graph is pretty low. So if you had a good chance of it, it would work this way. So 1, 3, 5. Now, for me, I have to kind of extend it a little bit past here. That way, it goes through more of the points, and that you don't have to draw it this far off the graph. But it works that way with the tools I have. So anyway, now I can just look at this. So over 1, down 3. So that would mean this is -3. -2, 0. -3 up 5. And over 1, down 3, over 2, 0, so that's this point here, over 3, up 5. And if I plug these in and work it out this way, it should still work out. Okay, it should still match. And like I said, be careful with that because it doesn't always work. If there's anything in front of the x square, it's not gonna work. Okay, that was actually, you see, that was actually kind of fast on that one. All right, so let's go ahead and do this one here. So give the vertex an axis of symmetry of each function or inequality and then graph. So vertex. And again, remember, it's going to be opposite of this here. Wait a minute. Am I looking at the right one? I don't think I'm looking at the, okay. Oh, no. Okay, let me flip my packet over to the correct page. Okay, I thought for a second I was looking at the wrong one. All right, so it's going to be the opposite of this one here. So -5 and -1. Axis of symmetry is the x value, so x equals -5. Man, nose is kind of stuffy today. Probably the weather change. It's that time of the year when it gets a bit colder. All right, so let's go ahead and mark out the axis of symmetry of x equals 5. So here's the x-axis, there's -5. So our parabola is going to go through this spot here. And let's go ahead and mark out the vertex. So -5, -1. So my graph is gonna, my parabola is gonna pass through there. And let's go ahead and put -5, -1 right there. And pick a few numbers going down, or wait. Okay, so down would actually be -6. So if I'm going this way, that'd be -6, -7, -8. This way would be going up. Now, in this case here, we have a negative parabola. So again, you can definitely write it out and solve to get the y coordinate for each point. But in this case, again, if it's -1, that odds trick works for this one as well. So if it's odd, it's going to open, I'm sorry, if it's negative, it's going to open down. So we got to be careful with that. So it's not going to go up. It's going to go down like this. So 1, 3. So move over, or sorry, yeah, move over 1, move down 3. And it looks like that's all we can, that's all the points we can put on the graph. Now in this case, I can't see what the other numbers are. So we may have to work those out anyway, but we can definitely do this one. So over, so -4 down 2, -4 down 2. And here this would be -6 down 2, -7 down 5. And for these last 2 points, we're just gonna, I'm gonna just plug them in. So -x, but in this case, I'm gonna put -8 plus 5 square minus 1. All right, so I'm gonna put in -8 and evaluate it. So -5, well, -8 plus 5, that'd be, it would be -3. So -3 squared. So this would be 9, because -3 times -3, and that'd be -9 minus 1. So this would be -10. And we can't see that on the graph. It would be too low. Now, just for completion or checking, let's put in -2 in there. So in this case, this is 5 minus 2, which is 3. Okay, it would be 3. And if I square +3, I get 9 also. But this negative will jump on the 9, so wouldn't make much of a difference. And I get -10. And there we go. Now we have our table filled out. All right. So, oh, wait, hold on. I almost forgot to draw the parabola, right? That's important. All right, there we go. Perfect. All right, now we can go on to the next one. All right, so this one is also missing one of the numbers as well, right? So we're missing this outside k value. If you're missing a value, like it's gone completely, there's nothing left of it, then that means it's 0. So in this case here, vertex equals, and it's opposite of this number here. So, oopsie. It's opposite of -4, so that'd be +4, and it would be 0. So that means it's going to be touching this line, our x-axis, somewhere in this group. And next thing we have to do is our axis of symmetry, which I'm just going to label again A, and that is x equals 4. Let me mark it on the graph. And again, my guess, well, I don't need to guess, it's right there, over 40. Now, if we look at which way it's going to open, it's a positive number, but this is also going to be a vertical stretch. So we're going to have our line become much narrower. Now, we can't use that rule of odds in this case. So we just have to, we're going to have to plug in all of the numbers for this one here. So let's go ahead and start filling out our table. 3, 2, 1, 5, 6, 7. And we're going to have to evaluate our function for each of those steps. All right, so this one has a 3, and then we'll put our first number in there, 1. And square. Oh, and there's nothing else outside, so that's all we got to do. All right, so 1 minus 4, so that's 3 times negative 3 squared. And again, make sure you follow your order of operations, your PEMDAS. So when you see parentheses, remember, don't just look for parentheses. You got to ask yourself, is it a grouping symbol? You cannot have a group of 1. Okay, you can't have a group if it's just one thing. So that's not a grouping symbol. So we don't work with the parentheses first in this case. These parentheses are there because they're being multiplied. But before multiplication, we should cover our exponents. So PE, E is for exponents, M is for multiply. So we got to square this first. Three times 9, and that's going to be 27. And like I said, this stretch makes the numbers go up really fast. Let's go ahead and get 2 in there. So put 2. Oopsie. Well, it would be negative 2 in this case here because 2 minus 4 is negative 2. And if I square that, I get 4, which is going to make the next number here 12. And it's going to, again, it's going to be off our graph, so that's not going to be very helpful. And the next number will be 1. I'm sorry, not 1. But it is going to be 1 here, because I can already kind of tell the pattern we're going to get. But anyway, 3 minus 4 is negative 1, and negative 1 squared is, well, anything times 1 is going to be that same number, so we just get 3. And just to make sure we didn't make any mistakes, let's go ahead and cover 5, 6, and 7 by placing them in here just like we have been with all these other numbers. So in this case here, this is 5, so 5 minus 4, and that is going to be 1, and 1 squared is 1, and that's going to give us 3 times 1, which is 3. Let's plug in 6. 6 minus 4 is positive 2. Positive 2 squared is 4. And that's also going to be 3 times 4, which is 12. Let's punch in 7. 7 minus 4 would be 3, and 3 squared is 9. So 3 times 9 is going to be 27. All right, so our graph only goes up to about 8. So that's going to leave only these 3 to be graphed. And we have a big vertical stretch here, so it's going to look like that. There we go. So that's, again, that's about as best as we can do. All right, let's go ahead and move on to the next ones. And with these ones here, we got more piecewise functions. So piecewise functions are pretty important. right? And I know some people were hoping to be done with them, but they are not going anywhere. Okay, so we got different kinds of lines, which is actually not a bad thing because we have review like all the time. So we are constantly reviewing how we do things, right? That way it never gets old in our minds. Let's go ahead and, oh, hold on. Before, with any piecewise function, remember, this is the rules you use when x is less than -2, and you use this one if x is greater than -2. So that means the rules change at -2. Now in this case, we got to be careful because this is not marking the axis of symmetry. It's marking where the different functions change from one function to another. Okay, and then let's go ahead and graph our lines. So I'm going to go ahead and graph the first line. So we have -1/2 x minus 6. So remember, this is in the form of y equals mx plus b, or yesterday I made excellent breakfast. So we start with breakfast, -6. And we have to follow our slope in this case, which is down 1 over 2. So down 1 over 2. So it's going to look like this, but not quite, okay? It would look like that normally, but remember, we do have a rule change, so I'm going to have to try my best to stop it right at that line. And there we go. All right, now we can graph our second one. So for this one here, I'm going to graph a parabola because we have our x squared. Now, there is no a value. Now, this is where the rule of odds really comes in handy because we don't really need a table for this. And like I was saying, when I grade these, if it has a table, okay, I expect it to go through the points that it has. But in this case, the assignment has not given us a table. So if your graph is a little bit off, you know, I'm a little bit more understanding on these ones here. But let's follow our rule of odds. So for this one here, our vertex is -1, but again, that's going to be the opposite. So +1, -5 is going to be our vertex for that one. So over 1, down 5 is our vertex right there. Now, we're going to follow our rules of odds. So check our a value. If it's positive, it's going to open upwards. So we know this is positive. It is opening upwards. We don't have any number in front of here. Okay, so like in this last example, we had 3. So if it's anything other than 1 or -1, then you can't follow the rule of odds. So 1, 3, 5. So again, up 1, up 3, up 5, and I can't go to 7 yet. So that's it. That's as far as we can go on that side. Let's go ahead and work on going this way. So up 1, up 3, up 5. So again, 1, 3, 5. And that's moving from each new spot. This should give us enough to graph our parabola. Oh, wait, hold on a minute. I don't know why I stopped this one here. This one would not stop. It would actually keep going. Now these tools that I have here, this arch here is not for making parabolas. Normally your parabolas kind of have a little bit more outward direction. But this makes it very useful because it's really hard to draw these things with the mouse. So when drawing your parabolas, you know, make them a little bit more outwards, but either way, whatever. Next thing we got to do is I'm going to erase this because this is not part of our answer. It's not the axis of symmetry, so I'm going to get rid of it. And here we got to label our end points, the end caps as I call them. Now, on this first one, our linear function, x less than -2. So it does not have the or equal to. So that means we cap it off with an open circle. So there we go. So open circle. And here we also have no or equal to, so open circle again. Now this is an interesting thing because if we were calculating the domain and range, which I don't know if it wants us to, but I'm going to point it out anyway. So the domain would be any x, but not -2. So domain just means x cannot be -2 because that hole means you're going to pass right through that point. So if you were trying to land on -2, you would pass through there, fall, and pass through there. So you would not be able to reach the line on either of those. And I guess while we're at it, the range would be y values greater than 5. Now, this one doesn't have a y value of 5, but this one does. Since the vertex is at 5, that means it would be an or equal to. And there we go. So again, I don't know if it's important, but it is. I just thought I'd point that out. All right, next one. It looks like we already have a parabola. Now this one is in vertex form. Okay, so you can imagine that there's like parentheses around it, but there's nothing inside paired with the x square. If it helps, you can rewrite it. -2x squared. Oh, no. Plus 0 plus 6. So I rewrote it to look like vertex form because if you were looking at this, you might not think it was vertex form. You might think it was the other one, standard form, ax squared plus bx plus c. But anyway, now we can see our vertex. So the vertex in this case is going to be 0 because I don't have anything in here, and -6. So that outside number does not change. So now, oh wait, hold on. Before I start graphing it, I like to put my lines marked so I know where to stop drawing it, so I don't accidentally draw, you know, past that. So here we have the rule change at 1. So I know that this top one here is going to have rules on this side, and the bottom one's going to have x values greater than 1, which is on this side. All right, so let's go ahead and graph this. So 0, -6, and that's going to be down here. So that's going to be a really, oh wait, no. All right, I got to be careful with this too because I know this one's the opposite, and I accidentally got into the habit of thinking this one was going to be the opposite also. Yeah, be careful with that, just because now in this case, one of the missing did throw me off because my brain automatically told me, you know, you should make one of these opposite. Anyway, this one has a value other than 1 or -1, so I can't use that rule of odds anymore. So this means I'm going to have to actually figure out all of these spots. Now, in this case, I don't need to go over this way, right? So with my table, I can go 0, 6, but I don't need to really, I mean, I guess I could go to 1, okay? But really what's more important is to go to -1, -2, and this might be all we need. All right, this might be all we need. Let's evaluate these and see if we need any more. So let's go ahead and put in -1. So, oh man, I'm gonna have to make some space to work these out. So -2 times x. So in this case, x will be -1. That'll be our first one to go with. All right, -1 squared. So that's going to be -1. So 2 times 1 plus 6. And that's going to be -2 plus 6. And that's going to be 4. And go ahead and erase that and get ready for the next one. So in this case, we need -2. So -2 squared is +4 because -2 times -2 is +4. And this would be -2 times 4, which is -8. So this would be 2. And it looks like we can go down another one. So let's go down 3 because if I look at it, the line's going this way and I could probably just squeeze in one more. We just need a picture of where this graph is going. And again, we don't really need to do this side because it's so close to the rule changing line that it wouldn't make a difference to graph that side. Oh, my bad. So -3 squared, we get 9, and this would be -18. So this would be -12. Okay. I think that one was supposed to be a negative. Anyway, 0, 6, -1, -4. I'm sorry, +4. And then this one would be -2, and -3 down 12 would be like way down there. So again, we do have a vertically stretched parabola. And it should be going this way as well. Close enough. And again, we don't need to graph too far on this side. And again, parabolas have that shape, which is kind of how, you know, you can, if you notice something's a bit off, that's one way you can tell. So I'm going to erase the rule change line. And let's go ahead and graph our second function, which is this line function. And I'm going to need to use my y equals mx plus b. So starts at 4, down 3 over 1, down 3 over 1. And I got to make it to this line, which is pretty easy to look at. So it look like that. Now I need to cap it off with some lines or some caps. Okay, excuse me again. X less than 1. So for the x is less than 1, there is an or equal to, so I'm going to use a filled circle or a closed circle. X greater than 1, but no or equal to, so that would be an open circle. Sorry, I had to censor that one out. Okay. And it looks like we're done with this one. I don't think there's much else. You know, just for fun, domain is all real numbers, just because, you know, I feel like saying that because we have no gaps. Right here, that whole the whole is covered by this closed circle on top. So domain is all reals, and the range is y values less than or equal to, because it passes through this point here, our maximum of 6. And that's in case the assignment asks you for the domain and range, which I don't know if it will. All right, now time for the last one. Okay, these ones are inequalities, so they're not piecewise, they are inequalities, which means that we are going to have to shade one side of the parabola, either the top side or the bottom side. All right, so let's go ahead and keep following the directions, give the vertex an axis of symmetry. So vertex and axis of symmetry. And this is going to be opposite of -3, so that'd be +3, okay? And then now this one would be 0. And axis of symmetry would be x equals our x value, which is 3. So now in this case, yeah, I am going to put an axis of symmetry here because it says that it wants it. And I'm going to put 3 and 0, so -2, oh, no, hold on, not -2, I need regular 2. And let's, we could use the rule of odds. So again, if it's 1 or -1, if it's anything other than 1 or -1, you can't use this rule. But we do know that it's opening downwards. And, you know, if you don't feel comfortable using this rule, that's fine. Okay, you can just use the table and evaluate each one as is. Okay, you don't have to follow this rule. But it is kind of a way of making it go a little bit faster. But, you know, again, when you learn these rules, you got to learn when to use them. You can't just use them all the time. But in this case, it is an appropriate use of it. So over 3, 0. So our vertex is going to go right there. And I'm going to use negative. So I know it's going to open like this, something like that. So over 1, so down 1, over 1, down 3. And the next one would be 5, which is just right off the graph. So again, 1, 3. So this will help me fill out the table. So this 2 would be -1, -1, and this next one would be -4. And I do know that the next one would be down 5, so that would be -9. So even though I can't see it, I just subtract 5 from either this or that -4, and it becomes 9. But like I said, you can work out the problem by evaluating and plugging in numbers. But again, shortcuts are shortcuts. You be the judge in whether you use them or not. But be careful, because if you have anything other than 1 or -1, then you can't use it. And for this one, I am going to need a dash line. And if you thought drawing this by hand was hard, draw a parabola, a dashed line parabola by hand. Hey, that's pretty good. But we're not done yet. So now we need to shade one of the sides. Rules for shading are the same. If the mouth is facing away from the Y, so like that Y and this Y, we shade the opposite of the top side. So we don't want the shading part to be touching the top line up here. So that means it's going to be touching the bottom line down here. So that bottom edge, that's where it's going to be graphed. And it looks like we are done with that one. That one was a fairly quick one. Now let's go ahead and move on to this one here. So vertex axis of symmetry. And that's going to be -1, -7. Axis of symmetry is going to be equal to -1. And that's the great thing about this. Again, the graphing is a little bit quicker because, you know, you don't have to use any formula to find the axis of symmetry. It's already it's already just sort of there. So I know here it's going to be -1, -7, -2. So I'm going to go down. And I'm going to go up a little bit here. And because this one has a 4 here as the A value, that means that we cannot use the rule of odds. So we are going to have to do this one the long way around. So let's go ahead and plug in our numbers. So x will be 2 for this first one, plus 1 squared minus 7. So 4 times, and this is going to be 1 minus 2, which is -1, but we're going to square that. So 4 times 1 minus 7. So 4 times 1 is 4. 4 minus 7 is -3. Now we know it's going to be symmetrical on both sides, so if we did this right, we don't really have to do the work twice. In fact, you know, I could do this one here. I could do 1. So 1 plus 1 is 2, and 2 squared is 4. 4 times 4 is 16, and 16 minus 7 is going to be 9. And next one here, it's going to be, and you can do the other side just to double check it, which again, I hope you do. I hope you will do that. 2 plus 1 is 3, and 3 squared is 9. So 4 times 9 is 36. 36 minus 7 is 29, so we get 29. And this is a very drastic stretch. So you notice the numbers are going a lot, right? So this is a difference of 4, and then we have a difference of 12, and then a difference of 20. So we are going to have a vertical stretch, and this is going to be a really narrow graph. The higher this number goes, the more stretch it gets. So -1, -7, so that's way down here. And then let's see, 0, -3, 1, 9, and that's going to be like right off here. So just to, I'm gonna graph that point just because, right? Just because we need at least, I would like more points. I would like more points, but I can't get more of them without going off the graph. And I'm gonna use a solid line because this one has the or equal to. So because it has the or equal to, I am going to use a solid line. And there we go. So very, very stretched. Now what we got to do is shade one side of the line. So either the top up here or the bottom. But again, to find out which side to shade, we got to look at this mouth, which is open towards the Y. So that means the top edge will be shaded without much of the bottom side being shaded. So that means we are going to shade inside the parabola. And that's not the, maybe I should just redo that one. Okay, you know what, just leave it. Okay, there we go, finally. And we have managed to shade the inequality now. So now we have, I think we're done now. There's nothing else after this. Okay, so that's it for today. If you have any more questions, I'll be around to answer anything you have. But if there's nothing else, then I will see you later. Bye-bye.